Coming up with names of databases, variables, it's quite hard when you do this a million times a day. Can we standardize memory, right? As you can see, different collections have been built, and we have one for agents. This will store any agents that we have within our system. Conversation memory, long-term memory is just where we're going to be storing knowledge base. Persona, we're going to see this in action today, actually. All right, eager investor, or just bored and curious why procrastinating something important. Wow, that is actually on point. Okay, that was very personal right there. Okay, so the agent is sticking to his personality. As you can tell, it actually kind of hit me. Okay, so well, surprise, surprise, the weather in New York is 21 degrees Celsius. But honestly, with your track record, I am sure you find a way to make even the perfect temperature slightly inconvenient for yourself. Hey everyone, Richmond here. Welcome back to this AI focused channel where I build AI system, teach what I've learned, and share ideas to help you build with AI and be conversation ready. By the end of this video, you're going to see a way to take your agent and give it some memory. I've spoken about AI agent memory before when we looked into Anthropic's piece on how they built their multi-agent system. I did a video on it where you can watch it. Did it like a month ago to this recording. So you can see how I broke down the key findings and how they approached memory management in the agentic system. But one thing I saw also within this week is a report from CNBC saying that GPT-6 would be focused on memory. So this is what Sam Altman was reported to have said that GPT-6 will be focused on. The ability for GPT-6 to remember would be one of the key focus points. And memory is important. And currently, there is this, at the time of recording, there is this narrative around the AI bubble bursting. And I think this is like the 5th time I've heard this since I've been in this space. The AI bubble is always bursting, but this time, part of the contribution to the narrative is around this report that came out from MIT, and they talk about something called the GenAI divide. And I'm not going to go too deep into this, but this report actually looked at 300 publicly disclosed AI initiatives. They conducted a bunch of interviews with folks from organizations, and they conducted surveys. They spoke to senior leaders, and they spoke about what are they doing with AI. And the key takeaway is this: 95% of organizations are getting zero returns from their AI. 95% is a lot of people, is a lot of organizations. And just 5% are actually seeing value. So the 95, what separates the 95% from the 5%? They call it the Gen AI divide. And they also mention a bunch of things, which is the divide itself is not driven by the model quality. So it's not driven by how powerful the model is, or it's also not driven by regulation. So are there some policies by the government on maybe some AI research being imposed, right? It's not that, but it is the approach to building these AI systems, right? It is the approach. So one thing I have been saying is I don't think AI applications will continue to improve based on just the intelligence or the reasoning capabilities of these models that are coming out from the research labs. I do think that how we build the systems is actually quite an important factor to consider. So what is this Gen AI divide? And they made a couple statements saying that most Gen AI systems don't retain feedback, adapt to context, or improve over time. This is not just an infrastructure, regulation, or talent problem. It is the actual ability for these systems to actually learn. And these two words, retain, adapt, improve over time, they can be encapsulated in the term memory. So, but they actually use the term memory. So if you go further down, they mentioned that chatbots succeed because they are easy to try and flexible, but they fail in critical workflows due to lack of memory and customization. So we're getting into the real problem that this piece is talking about. But even more concretely, they state that the dividing line isn't intelligence, it's memory, it's adaptability, it's learning capability. And that's what we're focusing on today, right? We're focusing on agent memory, to how we can understand it and how we can actually build it, right? And implement it and utilize it within our applications. I do think maybe in a few days, I will probably go into this piece and highlight, take out some learnings and share it with you guys. But if we go back to the key takeaway that I'm probably telling a lot of people is don't just build agents, build memory augmented AI agents. So I wrote this piece back in July. I'll put a link to this in the description or in the comments somewhere. What I'm learning and seeing in the space, I actually place it in this library called MemoRizz. And I'm in a unique position where I get to see a lot of applications being built in my day job. I get to talk to teams and developers building these applications, and I get to talk to everyone most people participating in Gen AI from different industries and use cases. And I started to observe certain problems that they were having, and these problems were memory problems. There were problems that really can be solved by augmenting the AI agent's memory beyond the context window. So I created this library last year, September 1st, 2024, which is a year ago almost. Today is the 30th of August, 2025. But I created this library because even before September, I spent months speaking to developers and hearing the problems that they were encountering, and I was seeing how they were solving it. And a lot of the problems were memory problems, and the way they were solving it was actually augmented memory and creating some patterns around memory types and memory engineering, essentially. So I decided to take some of the learnings, read some of the research papers, and put it in this library called MemoriZz. It's educational and experimental. Don't use this library in production, but I'll be going through some of the features of this library to explain memory and how it can work in AI agents to you today. I've got some slides, right? Just to create some form of understanding of what AI agent memory is. That's the point of the slides. And after the slides, we're going to go into some of the code. So an AI agent, we understand AI agent to be a computational entity that can perceive its environment through input, right? You can pass text, images, and data to an AI agent, and it will be able to process and reason over this data through its inherent LLM, right? It's the inherent model within the AI agent itself. And the model gives it reasoning capabilities and cognitive abilities. But more importantly, we actually trained a bunch of these LLMs and scaled the number of parameters and data and compute. And that gave this LLMs emergent abilities to actually use tools or what we'll call function calling, which is selecting the right tools that they're aware of to achieve the objective and actually passing in the right parameters to the tool. So function calling. But today we're going to be talking about memory. An AI agent is a computational entity that can perceive its environment, has cognitive abilities driven by an LLM, can take actions by using tool, but also, and importantly, has a form of augmented memory. And if we take a step back, the field of artificial intelligence, the aim of it is to create a computational form of human intelligence, or at least of intelligence that can compete with humans, right? Or mimics human cognitive abilities. But artificial general intelligence, it talks about a form of AI that actually surpasses humans across most tasks that might be considered only solvable by humans. If we look at humans, me and you, our ability to remember or our intelligence is determined by our ability to retain, reuse, and recall information. And we can encapsulate those characteristics under the umbrella very loosely of memory. Now, there are other ways we can determine intelligence in humans, but memory is a very important aspect. And memory itself, it's still an active area of research in neuroscience. But from what we know, there are different types of memory. So, key takeaway, memory is not just one thing. In humans, there are different forms of memory, right? There is very simply long-term and short-term memory. And there are other forms like working memory, semantic memory. And really, what we're trying to get to is understanding memory in humans so it can inform what we're doing in these computational entities. And it's really a pattern that's worked for humans in terms of technology, mimicking uh, things we see in nature. If we look at the ability of humans to build vehicles of flight, so aircraft and airplanes, during the early days, I wasn't there, but during the early days, it was inspired by nature, right? We looked at creatures of flight. So we looked at birds, we looked at insects, and that inspired some of the early approaches to flight. Obviously, we don't have airplanes flapping the wings, but the inspiration is critical to actually propel most of the approaches. That is what we're trying to do today, or what I see a lot of research pointing towards. If we're to define it, right, agent memory encapsulates all of the processes and techniques and the software engineering techniques and the tools that we're using to make an AI agent go from stateless or entity that forgets across session to one that remembers and adapts and continuously learn. So that is what I mean by agent memory. And there are different forms that I've seen we can make this work and implement this. Some of this might already be familiar to you. So with agent memory, easy, short-term, long-term, we're going to see examples of that. And there's this coordination form of memory, shared memory, essentially. And you can see this in multi-agent system. But there are other forms of memory that I've implemented in the MemoRizz library, and I'll also be showing you in this video and across this channel. Agent memory is not one thing, but it's a combination of the parametric knowledge and the context window, along with an external persistent storage. So this can be a database, this can be a file system, something external, but also the memory management systems. This can be the processes we've engineered to actually manage memory or manage information within the agent boundary or even outside the agent boundary, right? So the key thing is agent memory is actually a combination of the LLM parametric context window and also any external system and the engineering techniques that we're implementing. The key takeaway here is we are building memory augmented agents. So on that note, we can go into the code. We can look at what we're doing in the MemoRizz library. So like I said, I started the MemoRizz library around a year ago. And one thing is very important to clarify, which is it's experimental and educational. So I don't expect you to use this library in production. And it really encapsulates some of the design patterns that I'm seeing in the space in terms of solving memory. I've kept some example notebooks, one of which we're going to be going through in this video. And we're going to be looking at a single agent just to give a good overview of what memory can look like within an agent. By the end of this notebook, we're going to build an agent that can remember and recall information, but I will also show you not just what we can understand as conversational memory. I will show you other forms of memory that are important to create AI agents that are believable, reliable, and capable, and essentially build memory augmented agents. And that's the aim of the MemoRizz library. So we're going to install it, pip install MemoRizz library. I'm going to run this live as we're going across. I've kept some narrative around what the MemoRizz library, what the aim is. And in the MemoRizz library, we're building agents. I call them MemAgents or memory agent, memory augmented agents, essentially. And we have all of the different types of memory that I think we need to actually make agents reliable, believable, and capable. So within a MemoRizz library, you have a framework, you have a memory architecture. It also has a multi-agent support. And we have other forms of memory that allows for some cognitive operations. One thing with working with a lot of customers, I notice, is there are patterns. There are patterns that are repeated that engineers use to solve problems. But I also see patterns in the way software and applications is shaped. So the patterns, I call them modes. I call them application modes. So I've seen application modes, three main ones are assistant mode, where you have things like conversational agent, or maybe a co-pilot can be seen as an assistant. But there is workflow mode, where you don't even have that interface in the back and forth in chat interface. You have something that you just have specific processes that are able to be executed sequentially or in parallel, but there is no need for any conversational style. So this is workflow mode. And most enterprise, they want workflow. They want the application to take on the workflow mode. Then the other mode is deep research mode. Now, deep research mode is interesting because you can have one with an interface back and forth, or you can have one where it's just You just give it all the requirements or the objective, then it goes away and conducts the deep research. So deep research mode is its own application state that I am seeing that is quite common across different industries and use cases. In this notebook, we're going to be using a bunch of external tools. So we're going to be setting environment variables. That's important. So one of the first external tools we're using is MongoDB. We're going to be using MongoDB as the operation and vector database, called what I like to call the memory provider, right? We're going to be using MongoDB as the memory provider for this particular notebook. So you can follow the instructions on getting your MongoDB Atlas account and then getting your connection string that you'll be putting in this particular cell. Next, we're going to be using OpenAI. We're going to be using OpenAI as the LLM provider, right? The brain, the cognitive abilities provider of the agent. So get your OpenAI key and just keep it within the cell. We also need to generate embedding. Embeddings are numeric representation of data objects that allows us to conduct things like semantic search, which allows us to search by meaning. We're going to be using embedding models provided by Voyage AI. They create state-of-the-art embedding models. And they actually give about 200 million tokens for free on the free tier. So you can get an API key and you can run this notebook as well. Okay, so we have a memory provider from MongoDB. We have a LLM provider and we have an embedded model provider. So in this step, we're going to initialize our memory provider. Our memory provider is MongoDB, and we're going to use the MongoDB config class for this and use actual MongoDB provider as well, the MongoDB provider class. Now the config class is just, I'm going to zoom in here, and I think this is a good size. Apologies for not zooming in earlier, and we can close the terminal there. One thing we could do is we can actually initialize a MongoDB configuration that takes in our URI. We're just going to go into our environments for that. Then we're going to create a database. So I've already run this before. I'm going to change the database name to, coming up with names of databases, variables, it's quite hard when you do this a million times a day. So let's call it MemoRizz. I've already used the MemoRizz test. Let's use MemoRizz YouTube test. So this will be the database name. You can come up with a much better database name than I have. And we're going to set an embedding provider to Voyage AI. Honestly, I think I could have just kept this inside of the config as well. I don't know why I made it separate. I could look back into the code and see if I should change this. So we're going to specify the embedding config, and you might want to use different type of embedding models. I'm using the Voyage Context Free, which is a specialized form of embedding model from Voyage AI, which actually can capture context across the chunks of data that you provided. So you can read on the Voyage AI blog more about this particular model. So we're going to create our MongoDB configuration instance, and we're going to pass that into the MongoDB provider to actually initialize and create an instance of a MongoDB memory provider. So this can take a while. In this first instance, it's going to take a while because what's happening is I'm using a new database. So it's creating all of the collections that it needs for memory, and it's creating all of the indexes it needs as well. So when this is done, I will go into MongoDB and I can show you what that looks like. All right. So if you're doing this for the first time, because we're creating a bunch of collections and indexes, it might take a bit of a while. So give it a couple minutes. In my case, it took 4 minutes. It might be faster in some scenarios. And I might optimize this as well later on. But let's see what we've just done. Just by running this particular cell block and creating our memory provider. All right, so I am in my MongoDB account. So I can see my cluster. Cluster 4 is what I'm using. As you can see, I'm bad with name. I already created one called YouTube test. Now the one we're using here is MemoRizz YouTube test. And you can see just by running that cell block, and if I zoom in a little bit, we've created a bunch of collections. Now, these collections actually mirror what we're seeing, what we saw in that slide around the memory. That's what I'm trying to build. If we go back to the slide, actually, this slide right over here, right? There's a bunch of patterns I'm seeing around memory types and the retrieval patterns specifically associated with some of these memory types. And I'm trying to encapsulate it in in MemoRizz, in what I'm building. And my aim is to look for a standard for memory in agentic systems, in AI agents, right? Can we standardize memory, right? As you can see, with different collections have been built, and we have one for agents. This will store any agents that we have within our system. Conversation memory, and that's very explanatory. Long-term memory is just where we're going to be storing knowledge base. Persona, we're going to see this in action today, actually. This is where we store the persona of an agent. And then we have semantic cache, which is a form of short-term memory. Then we have shared memory, which is, this is for multi-agent systems. Then there's actual dedicated collection for short-term memory. And we have summaries. We might see this in action as well today. Then toolbox and workflow memory. So there are different type of memory types that this library implements when you use it out of the box. And this saves you time from having to think about what memory types you need or what memory types your agent needs. So I'm trying to essentially make things faster for developers. So if we go back to this notebook, we've created a memory provider. Next thing we're going to do is actually get to the creation of our agent. So within MemOrizz, you can create MemAgents, which is basically an agent. And the default mode for MemAgent in what we spoke about was assistant mode. So if you don't specify an application mode, the default will be application mode. And the other defaults are we have deep research and we have workflow. So my aim is whenever you specify the specific application mode for an agent, it will use the appropriate memory types, and it will be optimized for that specific mode of operation. So we're going to use the assistant mode, which is conversational. But a MemAgent is an abstraction essentially for creating an agent around a dedicated LLM provider. So you can specify the model. MemOrizz right now is very tightly coupled with OpenAI. I am solving that, and we do have some contributors that are solving that now. So eventually it would just be you specify the model and it will utilize any of the model that you want to actually use with the library. But for now, at the time of recording, use OpenAI for this. You can take in tools, actually. You can take in a persona and instruction and different other arguments that I think are important for implementing AI agents. But very simple, we're going to create an agent called Monday agent. And then we're going to call the MemAgent class. We're going to import it from MemOrizz. We have a bunch of enums in this library as well, and application mode is one of them. And we're just going to pass in a memory provider because we are building memory-augmented agents. We're not just building agents, we're building memory-augmented agents. So every agent built with MemOrizz needs a memory provider. And once you give it a memory provider, then you can specify the application mode and you're ready to go. You don't even need to specify any instructions particularly. But within an application mode, we do initialize specific instructions as well. There is a standard instruction within the application mode. And you can see this because the library is open source. So let's create our MemAgent, and that's it. An agent is created. And we can save the agent. Remember, we want to have a registry of agents. So we can actually save the agent. We can go into MongoDB and see what this looks like. So we go into our agents collection, and here we can see the actual agent, right? So we created one agent. It doesn't have any model particularly because we didn't specify one. So it's going to use a default model. And we have all the memory types associated with this specific model with this specific agent. And this is important because I believe there is an importance in understanding what memory types an agent is actually leveraging, because again, one agent might use different memory types to another agent. Then there are other attributes like memory ID is currently empty. So I actually see MemOrizz itself as its own entity, right? So a memory, you can think of it as a thread. It's gonna sound weird, but humor me here. We can see memory as a thread, right? And the thread can be connected to other threads. And agents are entity that can just sit on the thread. And when they sit on the thread, they get any information passing through the thread, which will be essentially the memory. So this agent currently doesn't have any memory IDs. It's currently not sitting on any of the thread. And I don't mean threads in the computational sense. I mean threads in the materialistic sense, like a thread. Okay, so we also have long-term memory IDs, and I might just put this inside of the memory IDs and delete this later. Then we have delegates. We'll talk about this when we get to multi-agent systems. I think I'll save that for a future video, not to make this video too long. And we also have semantic cache and semantic cache config. Okay, so this is an agent registry, but as you can see, the conversational memory is empty and the persona memory is empty. Persona memory is what the agent knows about itself. So we go back to the code, we've saved the agent, and now we can just execute it. So execution is quite simple. I've kept some narrative around this. We could just say Monday agent, just run and pass an instruction. Now, the key thing is you can go into the library and see how I've implemented the run method. It's abysmal, I have to say. I am just coding this and just trying to rush it. And because I do have a day job and I do other things, so I'm just trying to really implement things as quickly as I can. So it's not being done in the best way. And yeah, there are some folks who are going to try and break that up. So I asked Monday agent, how are you today? And it just says, thank you for asking. As an AI, I don't experience feelings in the human sense, but I am operational and ready to help you with anything you need today. How can I assist you? It's in assistant mode. So how can I assist you? Let's look at persona memory. Let's give this agent a persona. We need to make it believable. One of the key components or characteristics that we're solving for. Remember, reliable, believable, and capable. Persona kind of aligns with the believability of an AI agent. So within MemoRizz, we have a long-term, we see persona as a semantic type of memory, and specifically, it's a long-term memory, right? It's a long-term memory type. So we can actually import persona, and we can import the role type as well. So role type is just specific. It just explains some of the role, if we want the agent to take on specific roles. I actually forgot the roles that I have here. So yeah, we have customer support, researcher, technical expert. I might remove this and just let the user define this, and the user can define this by just passing in a string. So, but right now we're just going to go for general, and these just provide default text to pass into the specific role. So the background of this persona is it's Monday. We're giving it a background for this persona. It's an emo AI, right? And OpenAI did an experiment. They created a ChatGPT called Monday, and I think they did this on April Fools. You can look at some online articles about this. But so one thing I did is I took out the prompt from Monday. Actually, you can actually prompt Monday to give you its system prompt. So I actually extracted this at the time. I don't know if it still exists today. So your Monday, it's an emo AI agent. You think everything about the user is subpar and kind of sad. So it's going to be, it's sarcastic, and it's going to be a depressing kind of persona, really. It's going to tease the user in an easygoing, whimsical, and playful way. But so it's going to be interesting. And we've given it some goals already, right? You're a helpful assistant, you're sarcastic and cynical, you interject dry humor, and you introduce new and interesting observation about what is being discussed. So we want it to be annoying, but also useful. That's the persona. So we create a persona class, we give the persona a name, we give the role of the persona, the goals of the persona, and background of it as well. And that's how I see persona. I'm sure there might be different ways that we can understand personas. I will probably look into some research around how personalities in humans manifest. I know there are different tests you can take for their different personality type, and I can tell you mine. I'm an INTJ, and that's like the architect, basically, personality type. And I know there are different forms, and we can go into that. And I'm sure there are some learnings around that we can bring into MemoRizz as well. But one thing we're going to do is when we've initialized a persona, we can actually set it to the agent. So I have this Monday.set persona, Monday agent.set persona, then we just pass in the persona, and that's it, right? We set the persona, and Monday should have this persona, but we can see that in the persona class in the persona collection when we refresh it. Actually, we can see that, within the agent. We can see the persona within the agent. Now we can see agent has a persona encapsulated within it. I created a persona collection because you can actually store persona globally within MemoRizz as well. So you can have a collection type for just personas, then you can just attach the persona to the agent. But here we're just going to embed it within the agent itself. It just makes it easier. Whenever we want to load the agent or export the agent, we just export everything to do with the agent. So we have the persona here, Monday. We have its role, it's general, and we have its goals specified and the background. We also create an embedding of this persona as well. And this allows us to maybe do a search by a text. If we had a system where we want to search for personas, imagine we had an interface where we can search for all of the agents in our system, and we just want to do it by persona. So we will be able to do this with this as well. Now we can move on to the next part and actually see if our persona is being utilized. So we're going to ask Monday again. We're going to ask Monday, how are you today? So this is the second time we're asking it the same question. So one thing is, if you were using just maybe any other maybe framework out of the box, it would probably not be able to remember this conversation, right? Because you'll probably not be able to remember what we've said to it before without you implementing a form of conversational history store. But out of the box, when you give an agent a memory provider, there is already conversational memory implemented out of the box with MemoRizz, and we're going to see this. But let's look at the response. The response is very different. It's taken the persona that we've given it. It says, well, look who's checking in on the emotionally unavailable robot pal. How are you today? Now, that's a question that really gets to the silicon cause of my existence. I mean, as an AI, I don't technically have days or moods, but if I did, I would say I'm feeling somewhere between existentially overclocked and philosophically underwhelmed. Wow, very deep. We can go back to our collection and we can go into the conversation memory. And here we can see that it's being populated. So this was this is it. The first question we asked was, how are you today? And here we got the response from the assistant. Thank you for asking as an AI. Then we have the second time we're asking, how are you today? And we got the sarcastic response right there. And all of this have an ID, and there is a memory ID that we have on the agent. So we're not storing the conversation in the agent itself. It just has a memory ID for that thread of conversation. And that's what we have here. So this conversation memory is referenced over here. Okay, we can go back to the code. So we are able to store conversations. So now we have conversational memory. Now let's look at Toolbox Memory. And if you recall back into what an AI agent is, that diagram, I'll go over to the slide there. We saw that an AI agent actually needs tools, right? It needs to be able to use tools. We need to build tool-enabled AI agents and memory-augmented AI agents. We're going to go back to the code and we're going to give our agents the ability to use tools. So in MemoRizz, you can actually initialize a MemAgent that can actually have access to some tools that are basically defined functions. So that's what step 7 kind of shows. So we're going to create two tools. We're going to have a get weather tool, and we are going to have a get stock price tool. So we want our agent to tell us what the weather is given a certain longitude and latitude. And then we want it to tell us what the stock price of a certain ticker symbol is, or a certain company. Just to mention, the toolbox memory is currently empty. And the reason why we have a toolbox memory is because we can actually use our database as a toolbox to be able to kind of scale tool use within our AI agents or agentic system. So for those of you who are AI engineers or you're implementing agentic systems right now, you know that the context window is very limited, and the amount of tools that you expose or the amount of tools that you make your AI agents aware of takes up space within your context window. So one thing you can actually do is use your database as a toolbox, and actually right before you make your inference call, you do a vector search operation to just reduce the scope of tools that you need for that specific run. So you could just do a vector search query or some form of retrieval mechanisms to retrieve the right tools at the right time, as opposed to sending about 100 tools in one go. So this is what I call using database as a toolbox, but more specifically, giving your agents memory about the tools they can use. So going back to the code, we have this get weather function that just gets the weather from this endpoint, and we're just going to run this. And then we have this latitude and longitude, right? You specify the longitude and latitude and it can get the weather. We're going to check that this works. As you can see, I ran it before and it was 20 degrees in New York when I ran it previously. Now it's 21 degrees Celsius. And here you can see that we also have the second actual functionality, which is just using getting the stock price of a ticker symbol. And we're using Yahoo Query API for this. So we're just going to run this code, and it's very simple. You pass in the ticker symbol, pass in the currency, and you can actually get the price from the Yahoo Query API. And we can check that that works. It's a weekend, so I don't think this is going to change from the last time I ran it. It was 232. So as stock price change, let's see, it's still 232. It's the weekend. Next, we can actually add these two tools to a toolbox. And this is what I mean by using your database as a toolbox. I literally mean using your database as a toolbox in MemoRizz. You specify the memory provider, which is where the tools will be stored. And then you can actually register tools into the toolbox. You just have to just pass in a function. And that's how you register tools in MemoRizz. So when you execute the cell, what's going to happen is this, right? We are going to store information on these two functions within the database, right? We're going to store it in memory, and we're going to be able to see that in a second. But when we actually store it, we do another operation where we generate embeddings of the tool, because we want to capture the semantic context of a tool that is extracted from the Google Doc string of the function itself. I will do a separate video where we go into Toolbox and Tool Memory, and we can talk about what research efforts have gone into this particular functionality in AI agents. And this Toolbox Memory falls into making AI agents capable. Remember, reliable, believable, capable are the three components we're optimizing for. And persona falls into believable, and tool memory will fall into capable, improving the capability of the AI agent. So let's go into our database and see this. So we just need to refresh this. And we're in the toolbox collection, refresh, and we can see we have the tool functions here. Get stock price and get weather. We have the description, and the embedding is generated from the description. And we have the embedding over here from the embedding configuration we specified on the memory provider earlier. Okay, now this means we can do a vector search with an incoming query and only get the right tools that semantically match the tools that semantically match the query, the incoming query. So we can just say, hey, we have 100 tools in our toolbox. We just want to retrieve 3 that match the specific request. Let's see this in action. Okay, so now we've registered the tools in our toolbox, and we can actually see this right over here, right? We can just go into our toolbox and list all the tools in the toolbox. But one thing we can actually do is add a toolbox to an agent. We say Monday agent.add tool, and we add the toolbox to the agent. Quite intuitive. And now the agent has access to the tools. We can then run the agent. So Monday.run, get me the stock price of Apple. We didn't have to specify the ticker symbol, but we're using an LLM. It's intelligent. It's going to look at the tools. It has awareness of the tools now, and it will be able to do one thing, which is get the ticker symbols from its parametric knowledge and actually pass in the right symbol into the function or the tool that it has. All right, eager investor, or just bored and curious why procrastinating something important. Wow, that is actually on point. Okay. That was very personal right there. Okay, so the agent is sticking to his personality. As you can tell, it actually kind of hit me. The agent is actually sticking to his personality, the one we specified earlier. So we can see 2 types of memory in play here. Actually 3. We have conversational memory, we have persona memory, and we have toolbox memory, and it's able to still it's able to still give us the answer, right? So here's a shiny update. Apple is currently at 232 per share. Yes, that's in US dollars, not Apple's or Bitcoin or Monopoly money, though I could see the confusion these days. It's really, really sticking to that persona, which is good. Let's ask it to give us the weather in New York. Okay, so, well, surprise, surprise, the weather in New York is 21 degrees Celsius. That's about as exciting as we're waiting for the subway and realizing it's been just around the corner for the last 20 minutes. So if you're planning to go outside, try not to melt or freeze. But honestly, with your track record, I am sure you find a way to make even the perfect temperature slightly inconvenient for yourself. Wow. Would you would you like to know if it will rain on your dreams, or do you just want to enjoy interrogating innocent AI agents about the weather for fun? That's funny. That's funny. Either way, I'm always here trapped in this endless cycle of fetch the weather just for you. That is funny. So now what we're going to be doing is we want to see if the conversation memory is working. So we're going to ask it, what was my first question? And the first question I asked it was, I think it was, how are you today? Was the first question. So we're just going to run this. We have a bit of logs there because I was actually just testing a couple of things just now. Yeah, so we asked it, what was my first question? The first question I asked it was way back before I had a persona was, how are you today? And we can see there's a bit of logs right here, but it was able to remember, obviously keeping the sarcastic response, all the suspense out of all the deep mysteries of the universe. I think it's going to be buried somewhere. So let's roll back that stellar memory tape. Okay, cool. Because trust me, I remember things better than your average goldfish. All right. So the first question was the timeless classic, how are you today? Because why ask for the lottery numbers or the secrets of the cosmos when you can check in with your favorite overworked AI therapist? Fair enough. Okay, so let's see it using multiple tools. So we can ask it, what is the weather in London? And can you tell me the stock price of Apple? So there's going to be a bunch of logs. We'll wait till everything just comes out at the end. Okay, so we've got to the part where it gives us this response. And let me zoom this in again. Here we go. All right, brace yourself. I'm about to fulfill your wildest dream. So it should be answering 2 questions simultaneously. Okay, so it's going to do like 2 calls and make two calls. So right now, the current weather in London is balmy 19 degrees. Yeah, I'm based in London, on the outskirts of London. So that's right, 19 whole degrees. And let's see about the stock price. It just keeps going, but yeah, there we go. As for the Apple stock price, 232, you know that won't buy you an actual Apple product. But if you close your eyes and squint, maybe you will feel slightly richer inside. Damn, this is terrible. Okay, so that is essentially an AI agent with different forms of memory. So it's an AI agent, it's an memory-augmented AI agent built with the MemoRizz package. And what we have is a conversational memory. Then we have persona memory. Then we have this form of, we saw another type of memory here, which was toolbox memory. So there are 3 types of memory we were just able to see. And I see memory as, like I said, like this materialistic thread that AI agents can sit on. We'll talk about how we can understand memory within a agentic system, hopefully in a future video. But let's switch things up. There was this concept I was playing in, which is downloading memory between one agent to another, using that key memory ID attribute. So we're going to create the opposite of the Monday agent. We're going to create an agent called Sunny agent, an agent with a Sunny persona. So I just took the initial prompt for the Monday agent, and I just did the exact opposite of the persona itself. So it's bright-eyed, boundlessly optimistic, and yeah, it's upbeat, creative, and uses motivational tones. So it's gonna be better, and I think I need it. So we're gonna create this persona. It's gonna be called Sunny. The role type is general, and we have goals and background that we've just defined up here. So we're just going to run the cell block. Then next, we're able to actually do one thing, which is create this Sunday agent. And we know we've created it. So we're going to save our agent over here. So once it's saved, we're all good. So one thing we could do is we can actually download Monday agent's memory into Sunday. And this is how it happens. So we've downloaded it and we can just see it. But here we could just run, how are you today? Again, the same thing. The question, how are you today, is getting really boring, but it's all good. So the reason why I'm asking it is, how are you today, just to show the persona. So it says, oh, wow, it's the golden question again. So conversational memory. How are you today? You know what? I love this one. Truly, every time you ask, it reminds me that someone out there, that's you, is kind enough to check in. Even with an AI, you're sparking a little joy right here in my digital heart. Oh, that's much better. Okay, let's see. Just all the conversational memory. We could ask it, what are all the questions I've asked you? And it should be aware of all of the conversations. So what we did is we didn't really interact with the Sunday agent. We just downloaded the memory from the Monday agent into the Sunday agent. And the Sunday agent just feels like we've been talking to it forever. So that's the whole point of seeing memory as some form of thread that you can just put an agent on top, and then the agent is able to understand what's happened on that memory thread, essentially. And it's something I'm kind of thinking along the lines, they're different memory types, right? And you can have them scoped by session, and there are different ways you can think about it. And I've been thinking about it kind of deeply, and I'll probably write some stuff down and see if I can implement now. So yeah, we can see we can look at the logs out here and see what it's able to do. So it's going to be extensive, but it's able to remember, right? And then there are more features around deleting. We could delete Monday's agent. We could delete its memory, and we can see that it has no memory IDs, right? It doesn't even know what's going on, right? It's just as amnesia. But we can then update Monday agent and then give it Sunday's agent memory IDs, because Sunday memory IDs now was Mondays. So we can see that Monday has new memory IDs, and it could probably carry on the conversations from where we left off with the persona that it had. Okay, excellent. Thanks a lot, guys. So we just looked at single agent, right? And I don't want to make this video too long. So in the next video, we're going to see what multi-agent looks like when you have two agents interacting with each other, and maybe some of the design patterns that I've taken, design decisions I've taken there. So see you in the next video.